Welcome back. We're writing Little Man Computer in C++, and we've got nearly the whole thing there now. We've got a computer with all of the component parts of that. We've got a little man that runs around and interprets instructions and follows the program counter as it moves around. But the one thing we can't yet do is handle the ability to have multiple values in the inbox that change over time. And so I thought we'd have a go today at dealing with that issue. Now this this could go horribly wrong because I'm not entirely sure how best to do this, but we'll, as always, start by writing a test and to try and capture what we actually want to do with this. So if I go to the bottom of our tests here, what we kind of want to say is well, let's leave the name for a second and let's actually write out what we want the test to do, and then maybe a name will jump to mind. So we kind of want a program that looks something like this. So we want to say input. So we put the input into the accumulator, and then store that somewhere in memory, which we'll work out in a second. Then take a second input that's different, add the original value that we just stored into memory, and then, I mean, that's probably sufficient because we can assert on the we can assert on the value of the accumulator after that addition, so that should be fine. So that's 901. So how many? So this is 0, 1, 2, 3, and 4. So storing in 5 would seem logical. So 305, 901 again to bring a second value, and then what's the numbering? Add is just 1, isn't it? So 105 to get the value from 5 again, and then 0 to halt. So that's 0, 1, 2, 3, 4, and then the memory location 5, which we'll be using essentially as a dat instruction. And we could even perhaps zero that just to be clear what memory we're using there. So that's store address 5. So we've got a little program there that requires 2 distinct values from the inbox, and we'll make sure that we're checking that. So we need a computer. No, we're not starting immediately with the assertion here. We kind of know what we want to assert. We want to assert that the accumulator is the sum of these 2 values, but we can set this up first, and then a little man with that computer, and then we load a program, which is the program we've just written, and then we run that program, and then we assert equal, assuming we're just going to do 1 plus 2 or something, that the computer.accumulator is equal to that. Now this isn't going to work. Well, it should compile and fail with the accumulator being, I guess, 0, whatever the initial value is. or some random values. Oh, hello. Oh, we haven't got a name yet. That's actual 532, which is the random content, I guess, of the inbox initially. But what we can do, actually, just as a little setup here, just to see what this would look like, if we were to set the computed inbox equal to 1, then we should see that the test result is 2, as opposed to the 3 we'd like it to be when we can have 2 inbox values. Did I say input or inbox? Yeah, I said inbox, okay. So that's fine. So what we want to say is program with 2 different program requiring 2 different inbox values added sets the 2 different inbox values added results incorrect accumulator, something to that effect, and we'll see what that does. So we need a mechanism for setting up the little man asking for something for the inbox, perhaps. So we almost want. So the way I kind of like this to work when run in production, if you will, is to have this. Whenever there's an input instruction, have the little man first go and get a value from standard input, put it in the inbox, and then run the input instruction. So we kind of want to fake standard input or some generic iStream as part of the little man. So what would that look like? So we don't really want to have an inbox value predefined there. What we actually want to do here is we want to say that that there is some fake input stream input stream that is part of the little man. Now I have no idea what this is going to do. We're going to have to deal with things as and when they come. We haven't given a semicolon. That's fine. So we're going to need to create a few things here. So we don't have a fake input stream. That's a good start. That's nice and clear. So if we go up here before our little man, we're probably at the top here. So we've got our test result, we've got our test, and before our test fixture, what we kind of want is a class fake input stream, like so. That's so we've got this fake thing, and now our little man is missing the ability to take that as a constructor parameter. So if we go to our header file, we have this constructor here. I guess we need a second type of constructor, which takes a computer and something, is it something like that? Input stream. This is going to be a little bit of messing around because of my lack of knowledge of C++. So what do we have? No matching constructor for that. Candidate constructor is not viable. No known conversion between fake input stream and iStream. Okay, that's a good step in the right direction. So we can go to our fake input stream and we can say that that's an iStream. I don't know if we need to include anything or whether IOStream is fine. Hello, what have we done? Error. Call to implicitly deleted default constructor of that. Note, default constructor of fake input stream is implicitly deleted because base class iStream, aka basic iStream char, has no default constructor. I'm not entirely sure what that means. Let us get Googling. Default iStream has no, iStream has no default constructor, yeah. iStream has no default constructor. A privacy reminder from Google. That's very nice of them. It's not quite the right place. Let's at least look at iStream. So what constructors does that have? Is iStream maybe iStream is not an abstract class as such. So it looks like you can just, yeah, don't really want to have to do too much with that. So what's a good thing to look at? Can we look at the iStringStream.cpp? So that's an IOStream base. Is that where we're coming from? Whereabouts down this do we want to land? Inheriting from iStream. So maybe the easier way here. Maybe the easier way here is to, oh, that's going to be right, is to create our own input stream type. Yeah, maybe we do it this way. Much as it would be nice to use iStream, I think we're going to spend too much time messing around with that if we do go down that line. So instead what we can do is we can say, let's make this an input stream, and make this an input stream, which we are just making up. We're going to have that as our interface that we're implementing, so that doesn't exist. So now in here we need to go and say class, how do you create a pure abstract class in C++? Pure abstract class C++. Is there going to be something easy to look at? No code. Just want an example. Do we have to use the keyword abstract in the class definition? Do we just have virtual members? Looks like that's it, isn't it? So virtual members should be sufficient. So class input stream. That's all we need to do for now, because we haven't specified how we're going to use that. Ooh, hello. Undefined symbol for architecture. Intriguing. So LMC input stream. I'm guessing that that is because we haven't used LMC here, perhaps. Let us see if that's the particular problem. Nope, that is not the issue. Have I spelled input stream wrong on the previous one? So input stream. That looks correct. What is the issue? So undefined symbols. Undefined symbols for architecture. Undefined symbols for architecture seems to be something people have searched for before. Is it going to have something obvious? Yeah. So let's chip away at this a little bit. So we have an input stream there, an input stream there, and we have that there. So what if we were to delete that, and also in our test delete that and that? So we've just got it in the production code. Is it happy with that? Yes. So there's a problem in our code. Public. So we've got a class that implements public LMC input stream. Have we done that correctly? I do not know. let's take away these bits then and leave the class in here. See if that's where the issue is. Nope. Interesting. So, fake input stream, possibly an unused variable failure, but we will see what that does. Yes. So what if we were to do maybe unused? Don't know if that's allowable in the middle of code. It's fine. So let's get rid of that, and here use input stream. And this is where the error came last time. And that's going to be because we haven't implemented that constructor, as I'm sure you've been shouting at your screen for the last 5 minutes. So we have a little man constructor with a computer and an input stream. If I can type. Like so. That's not doing anything, but we'll check it actually builds. 3 errors. We're not explicitly initializing something. And then we have unused parameters and what have you. So that's fine. So what we want to do is we want to do computer and input stream. Well, let's not quite go as far as that yet, as we're not certain what we're doing. Let's take it in baby steps. Make sure that we can get to where we want to. Okay, that looks fine. And the tests all pass except the new one. So then we've got this. What we want to be able to do is something along the lines of that, and have input values 1 and 2 like that, and pass input values. So that's going to fail because we don't take the parameter. That's fine. So then we can go to our fake input here and have a vector called input values, like so. Is that correct, or have we done that horribly wrong? Input stream. Oh no, it's going to be private, so we can't access it like that, can we? So we'll need a constructor. Like this, fake input stream. That takes a a vector of int called input values, and then stores it like so. How does that get us on? Good. So, is there anything more we want to say in the test, or is that sufficient setup? So, we've created a little program that requires 2 separate inbox values. We've created a computer. We've created some input values. We've created a fake input stream with those input values. We've created a little man which takes the input stream, and we've created, and we've loaded the program, we've run the program. So now we need to, is there anything we need to do on this side? No. So what we kind of need to do, what we kind of need to do here did this want to be, firstly, just I'm tinkering here with constructor stuff. How are we setting the, that's fine, isn't it? Is it? I think that's still okay. No, private field is not used. That's indeed correct. We will mark that for now, just to keep the compiler happy. Good. So we've written the test as best we can now. We now need to make that pass without breaking all of the other tests. So we need some virtual function that returns something like next int. Is that fine? That's going to complain because we haven't implemented it, I hope, in our test. Maybe it's not. Maybe it's happy with that. Nope, no, we're good. So we need to implement that everywhere. So in our only implementation here, we need to say int next int Is there such thing as a standard queue? Would that be better than a vector if such a thing exists? But for now, let's just return 0 or return 1 and see where that gets us to. We might need to change our test API slightly. Type info for input stream, referenced from type info fake input stream. C++ override virtual function. Do we have to do something special? Let us see. So base, we've got a virtual void print, and we just create a function as normal. So have we That's in the public section. That should be fine. Have we named our function wrong? It's just called int next int. And we've called it next int there, so that's fine. So what is the issue here? Did we have to call it? No, that doesn't seem likely, does it? I was just wondering if we had to prefix it with the namespace, but sounds a little bit odd. So, undefined symbols for architecture, type info for that, referenced from, type info for that, symbols not found. Awkward. That all looks completely fine. Ah. That needs to be public, I think. That's the issue. Let us find out. Looks slightly more promising. Nope. Shame. Very close. I wonder what the issue is. If I comment that out, does it work? Yes. So the issue is that in some manner. So override virtual function C++ different namespace. Do we need to do anything clever? Doesn't seem quite right. But let's at least give that a stab, just so we can eliminate it. Cannot have qualified name. I guess that rules out that issue. I think we shall break there and return to it next time, after a bit of a think.